Hello and welcome to Jim's Radio Shop. And we're going to be taking a look at a Telefunken Jubilate radio. Here it is here. Apparently this radio is in working condition. And it's in, the cabinet looks to be in pretty good shape too. Unfortunately, the tops of these buttons have cracked and broken away. So that's really not possible for an easy fix there. We'd have to find another identical radio and move the buttons somehow. None of that's easy. So, yeah, a little tricky. Well, I'm just going to spin my radio around anyway. So, let's take a look at the back of it here. Okay. Now I've already vacuumed this radio out. It was very heavy dust all through here. Not so bad further up. And that tells me this radio has been sitting in one position somewhere for a long, long time. At some point in its life, anyway. So the capacitor here had a pile of funny stuff on it. It would appear to have come out of the top of the capacitor. Let's take a little closer look here. You can see the corrosion on it from the chemicals which have come up through a little tiny hole, which I've never noticed in the top of any other capacitor. So I'm curious about the hole, but in any case, I think we can bet this capacitor is shot. So we would expect this radio to hum fairly badly. Now there's some other areas here. These radios typically have a fuse sitting out on the back here. And it's a little like leaving it out in the weather. And you can see the corrosion that's occurred right on the fuse connection, right on the fuse clip rather. So we'll have to clean that up. If the radio's working, then the fuse is okay the way it is, but it doesn't look very good. It won't be reliable. There's a magic eye up in there, which is kind of cool. And one single speaker. It has these wires hanging out here, coming through this clip, which I don't think is normal. I'm not sure why it would come through there. A little mysterious. So we're not going to turn this radio on until we've examined it a little further and change the capacitors below here. So that's a quick look at it. Check out process. We're going to take it out of the radio and have another look at it. So let's with that. Away. There we go. Okay. So we have to, that didn't sound very good. Okay, we have to release the spring. Release the spring. There we go. Cardboard cover. And the tube is out and loose. Just set it there. And fairly long speaker wires, so we'll just swing the chassis out, which is the usual way of dealing with these radios. There it comes. I've already taken the screws out of the bottom, by the way, so that's why I big bad scratch on the inside back of the front. Or is that a cat hair? Well, that's pretty odd. Perfectly straight. Scratch down the back here. That's scratched a little bit of the writing off. And that one lighter looking pretty bad. Let's see what we got here. A little magnification. .3 amps. I'll replace that with a .3 amp light. And I'm just making an examination here of any other obviouses. Which there are not any other obviouses here. Let's turn this guy up. Okay. Yikes. I'm not going to see much under here, are we? Circuit board. Oh, I can see a crack forming in this plastic here. I'm not sure it's important at all. I think the plastic sleeve here is just a spacer, just providing rigidity to the button levers. So unless this breaks entirely and falls out, I don't think there's any effect on the radio. It will probably crack all the way through. Well, I mean, what's interesting is it's cracked. It's just sitting inside a radio and it's cracked. How does that happen without any stress? And of course the answer is there can be stress right in the plastic, right from the time it was originally made. And that slight stress is enough to allow cracking over a long period of time. Not much to see under there. That means all the parts are up on top here. Let's see if we can stand it up this way. Well, the wire is suspiciously just long enough for that. Okay. That's the speaker wire I'm talking about. So nothing obvious. Again, the word is that this radio works, so I shouldn't expect to find anything obvious with it. Yeah, other than changing the light. So we need a screw-in 0.3 light bulb. That's a good question. I'll have to hunt that down a little later. So I think I might as well proceed with the augmenting this capacitor. Now, how much is that? I don't have this circuit diagram in my hand. I should be able to read it here. 385 volts. Can't quite read the capacity. $50 plus $50, $350, $385, and 50 plus 50, $350. What the heck is that? I got that. Anyways, they're 50s and they're 50 microfarads and 350 volts. Can easily replace that. Oh yeah, that's right. It's on this crazy board. There'll be no clearances underneath here. So I think we need to remove it entirely and put the replacements up on top here, which is a little more work. This looks like the connection points, 3 connection points. Okay. Now you can't see anything because I'm working up high, so let's adjust this a little bit. There we go. Now, to get this capacitor out, held down in 3 places, I can't really loosen the solder in 3 spots at once. So we do one and work it back a little bit. And then move a bit. That one wants to move. Okay, another approach. We'll suck the solder away from each connection because I can't get these to come loose and start moving. Sometimes the capacitor will practically fall out when you do this. Other times it's in kind of with a mechanical. Here we go. Again. The solder sucker has a bit of a kickback when you fire it. Okay. This one. Oh, it's these 3. Okay, I got the wrong 3. This one's for something else. That might explain why it didn't come loose. But let's keep on with the solder sucking here. Yeah, the solder sucker has a kickback. It tends to jump away from the work at the moment you release the trigger. I don't think I got anything there. This is the one I didn't realize was the capacitor. Nothing there. Okay, let's try and wiggle this guy out now. Now that I know the 3 proper connections to work on, there goes one. There goes the other. There goes number 3. So practically fell out with the terminals, and here he is. Here he is, Mr. Excitement. 50 plus 50, 350, 385. Wow. Yeah. Why don't we put the voltmeter on that? Just for a bit of fun. Let's put the ohm meter on it. I don't want to put the voltmeter on it. Well, it's certainly not shorted. Again, if the radio is working, you're not going to expect that to test bad. So we need a couple of 450 capacitors here. Oh my. There's a 350 volt one. Come on, don't tell me I don't have them. Oh. My supply of parts may be low. No. Not paying attention to my parts box. Oh, I think there's a big O going on here. Oh man, I got some low voltage capacitors that would work in a transformerless radio with a low V plus, but rat. I'm stymied in my work. I don't even think this is even a proper replacement for the light. No, it doesn't look right at all. Let's see. This is a 46. I'll have to check the current draw from a 46. Well, I think that's about as far as we can get with this radio. Unfortunately, there's no reason for me to operate it. I could continue with the basic cleanup of it. And I'll have to run down to the shop. Okay, so here goes my vacuum. Okay. Now, else I noticed about this radio is the, oh, I see. With the screws out the bottom, and there were some screws missing. The front bezel on the cabinet is actually not fixed in place. Also had some kind of a tape just falling right off here. It's not in use. Oh, just some black, you know, it looks like hockey tape, really. Cloth tape that was used along the bottom here. Exactly why, I don't know, because I can't see right now. But may or may not have to replace that. Okay, Mr. Radio. With you and your capacitor, we'll throw you back in the cabinet. I'm going to have to secure some capacitors. From the shop. Okay, that's too bad. At least we know the situation with that one. That's the end of the checkout process. See you later, bye.